بسم الله الرحمن الرحيم. In this topic, we are going to discuss the rank of a matrix. Also, we are going to define the linearly independent and linear dependent set of vectors. Starting with the definition, what do you mean by linear independent vector and linearly dependent vector? So, let us say that we have a set of vectors u1, u2 up to u sub n is said to be linearly independent. If the vector equation given by C1 multiplied by U1 plus C2 U2 plus up to Cn UN equal to 0 has only the trivial solution. That is C1 equal to C2 equal to up to Cn. All of them are equal to 0. So if this condition is satisfied with this solution that all the constants are equal to 0, then we say that the set is linearly independent. Otherwise, we'll call it linearly dependent. For example, the vectors say u1 is equal to say 1, 5, or 3, and the vector u2 which is equal to 3, 15, and 9. u1 which is equal to 1, 5, 3, and u2 3, 15, 9. From this we can say that u2 is equal to 3 multiplied by u1. It means if we can write one of the vector as a constant multiple of another vector, we call these are linearly dependent. Otherwise, it will be linearly independent. So u2 minus 3 u1 equal to 0. That will give me C1 equal to 1 and C2 equal to minus 3. Or C1 is minus 3, just keep it in order. C1 equal to minus 3 and C2 equal to 1, which are not equal to 0. So in this case, we say that U1 and U2 are linearly dependent. Because U2 can be written as a constant multiplied by the first vector U1. If we can write it in this way, then we say they are linearly independent. Now the linearly dependent and linearly independent of vectors can determine the rank of some given matrix. And we can define the rank of a matrix. The rank of a matrix of M by N, matrix A, denoted by rank A is the maximum number of linearly independent row vectors in A. Since we have that A consists of row vectors given by A1 up to A1n, each one of these rows is called row vector of the matrix A. Now, if these rows are linearly independent of all of them, then we'll say that the rank is equal to M in this case. So the rank is the maximum number of linearly independent row vectors in A. The question will be how to find this number. Rank of A. This will be the main question for this lecture, how to find the rank for some given matrix. Before doing that, let's write some idea or remarks in the rank of a matrix by row reduction. So that if a matrix A is row equivalent to row echelon form. B, then a matrix A is a row equivalent to a row echelon form B. We said that A is row equivalent. Row equivalent means that if we doing some row operation for the matrix A, the result matrix B, we call it row equivalent for A. For example, if we add two rows together to replace one of the row of the matrix A, the new matrix now we call it row equivalent. Doing any row operation will give me new matrix. That one is row equivalent to the original one. And echelon form of some matrix B, for a matrix to be row echelon form, it is like writing the matrix in upper triangular form or lower triangular form. we keep the matrix in row form or in triangular form and keeping all the elements under that one to be zero, we call this is row echelon form. Conducting some row operation to generate an upper triangular matrix, keeping all the elements in the upper half non-equal to zero and the lower triangle equal to zero. We call it row echelon form. This will be explained with examples later on. Now, if you have a matrix A is row equivalent to a row echelon form B, then number one, the row space of A equal to the row space of B. Number two, row space means any vector can be written as a combination of these rows. The non-zero rows of B form a basis for the row space of A. This word basis means any vector can be written as a linear combination of the set of these bases. Any vector can be written as a linear combination of the bases. Third one, the rank of A equal to the number of non-zero rows of B. Let's see what the meaning of these 3 points. Take this example. Find the rank of the given matrix. Number one, say that A is equal to 3 minus 1, 1 and 3. I need to see or to find the rank of this matrix A. Or in other words, I need to find how many non-zero vector row in the echelon form. So just convert this matrix to echelon form. So we need to convert to an echelon form. Applying some row operation. Now for the row echelon form, we need to keep this element equal to 1 or non-equal to 0. I can use it as a reduced, or I will keep it as 1 because that will make it will be easier to do the row operation. Now to keep that 1 equal to 1, either I will divide the first row by 1, or I will swap between the first and the second row. Since I have 1 in the second row, I'm going to swap. I will say R1, swap it with R2, and write it as R1. So the matrix will be equal to 1, 3, 3 minus 1. Now this operation, we call it row operation. We can swap, we can divide, we can add or subtract 2 rows, or divide by some number, scalar number. So I can divide by scalar or multiply by scalar number, or I can add 2 rows or subtract 2 rows. All of these, we call them row operations. So the row operation means you can multiply by scalar or divide scalar, or we can add 2 rows, or we can subtract. These are the row operations. Multiply by constant, or divide by constant, or add or subtract 2 rows. Or we can also swap. What I have now is 1, 3, 3 minus 1. So I got 1 in my first entry of the first row. So we are done from this first element. Now I need to keep all the element, or just convert them to 0. I need this to be 0. We need to let the second or the first entry in the second row equal to 0. Also, we are doing row operation. I will say minus 3 multiplied by R1 plus R2. This will replace the second row. If you multiply the first row by minus 3, I will get minus 3 and 9. This is the first row, and minus 9. R2 is 3 and minus 1. Now add minus 3 and 3 will give me 0, minus 9 and minus 1 equal to minus 10. This will be the new second row. So the matrix now is equal to 1 and 3. Now change in the first row. Second row will be replaced by the new one that will be 0 and minus 10. Now if we divide, this is not necessarily, but we can do it. Divide R2 by minus 10 and put it in R2. I will have 1, 3, 0, and 1. Now this is row, we call it row echelon form. Now this is row echelon form, and we can see in this row echelon form we have 2 vectors None of them is equal to 0. I don't have any 0 vector in this matrix. So since both of them are not equal to 0, this will give me rank A is equal to 2. As we define the rank of the matrix, it is the maximum number of linearly independent row vectors. Since none of them is equal to 0, we call this is they are linearly independent and the rank of the matrix A is equal to 2. So I have another example. Number 2. A is given by one, two, 1, 3, 2, 1, 3, 6, 3, 9, minus 1, minus 1/2, minus 1, 3 over 2. So let's convert this to row echelon form. So I need to keep the first one equal to 1. Try to convert it to 1. Either I will divide by 2 to make it equal to 1, or swap between the first and the third one. Let me divide by 2. R1, divide by 2 and put it there as R1. So I will have 1 over 2, 3 over 2, 6, 3, and 9, minus 1, minus 1/2, and minus 3 over 2. So we are done from the first one, got equal to 1. Now I need to make this number equal to 0. To make it equal to 0, I'm going to multiply the first row by 6 or minus 6. Let's say minus 6 multiplied by R1 plus R2 and put it in R2. Minus 6 times R1 will give me minus 6, minus 3, and minus 9. R2 given by 6, 3, and 9. If we add, I will have 0, 0, 0. So this is equal to 1 over 2, 3 over 2. Now R2, the new one is 0, 0, and 0. Third row is minus 1, minus 1/2, minus 3 over 2. And so we are done from this element 0. So we have to move to the next one. Next one is minus 1. I need this to be 0. So R1, because I have 1 there with minus 1, I'm going to add R1 with R3 and put it in R3. R1 is given by 1, 1/2, and 3 over 2. R3 minus 1, minus 1/2, minus 3 over 2. We add them, I will get 0, 0, and 0. So my new matrix now, or the equivalent one, will be 1, 1/2 3 over 2, then 0 0 0 and 0 0 0. And it's clear that we have only one non-zero vector in this matrix. The other two are equal to 0. So in this case, the rank of this matrix rank of A is equal to only 1. So the rank of this matrix is equal to 1. Because we have only one non-zero vector. The other two are equal to 0. One more example. Number 3. Let A equal to 1 1 2 minus 1 2 and 4 minus 1 0 and 3. Convert this or to reduce or to echelon form. Let's find the equivalent matrix for this A in row echelon form. First element equal to 1. It's okay. No need to swap anything. Just keep it there equal to 1. Now second one, I need to keep this equal to 0. To do that one, let's add R1 plus R2 and put it in R2. We have 1, 1, and 2. The second row is minus 1, 2, and 4. I will have 0, 3, and 6. This will be the new row for the matrix. 1, 1, 2. I have 0, 3, and 6. Minus 1, 0, and 3. I need to make this equal to 0. I'm going to add R1 plus R3 and put it in R3. That will be first row is 1, 1, 2. R3 is minus 1, 0, and 3. And I will have 0, 1, and 5. That is 1, 1, 2. We have 0, 3, 6, 0, 1, and 5. So we are done from the first column. We convert it as 1, 0, 0. So now in this case, forget about the first row. Don't do anything or any operation with first row. Forget about it. Since we are done from the first column, we got 1, 0, 0. We will forget about R1. I'm going to deal with R2 and R3. Now for R2 and R3, I need to make this one equal to 1. Now, sometimes it's not necessary to do it equal, make it equal to 1, but let's make it equal to 1. That will be easier for the row operation. So to make it equal to 1, I'm going to swap between R1 and R2. Because I have 1 there in R3, I'm going to swap between R1 and, R2 and R3. And this will be in R3. Or just swap, there's no operation. I'm going to swap between R2 and R3. First one is 1, 1, 2. Then one will be 0, 1, and 5, 0, 3, and 6. So we swap between R2 and R3. Now I need to make this equal to 0. To make it equal to 0, I will multiply R2 by minus 3 or 3 R2 minus R3 and put it in R3. So I will have 3, 15 or have 0, 3 and 15. 0 minus 3 minus 6. I'll have 0, 0 and 9. So this is equal to 1, 1, 2, 0, 1, 5, 0, 0 and 9. And it's very clear that we have 3 non-zero vectors. The first row is not equal to 0, the second one is not equal to 0, and the third one is not equal to 0. If I want to make that equal to 1, I will divide by 9. This one, I can divide by 9 to make it equal to 1, but still it is not equal to 0. So this means since we have 3 non-zero vectors, the rank of A is equal to 3. So the rank of a given matrix is the number of non-zero vectors in the row echelon form. You can define in this way also. Rank of a given matrix equal to the number of non-zero vectors or rows in the row echelon form. And in our case, we have 3 non-zero vectors. So this is how to find the rank of a given matrix. Reduce it to echelon form and see how many vectors that are not equal to 0.